Hello everyone, welcome to Clashing Coder. So in this video we will see the question 187, that is repeated DNA sequences. So it is not a popular question, but let's see. So if you are solving this, so if you are not able to solve this question, so I will tell you the simple approach or simple way to solve this question. So let's see the problem statement. All DNA is composed of a series of nucleotides abbreviated as A, C, G and T. If you have studied like bio in your 10th grade or like below that or above that, so you will be knowing that there are like these four characters are there: A, G, C, G, T, which like this tells about the DNA. So this is a given sequence, and when studying the DNA, it is sometimes useful to identify repeated sequences within the DNA. So write a function to find all the 10 letter long sequences that occur more than once in a DNA molecule. So you can see this DNA molecule that they're telling about is of length 10. So you can see this is 10 character long, or 10 you can see the size of this will be 10. So we have to find, we will be given a string. You can see we are given a string, so we have to find, you can see all the long substrings. So substring is actually all the continuous strings inside this the large string. So like it is not the subsequence is where we can skip the characters in between, but in this substring we cannot skip any character. So if we are starting from this A, so we will have to count all the characters in between this A and the other A, which will be like 10 characters away. So what we have to do is we will be given, let me show you in the example actually. So yeah, you can see this is a input that we are given, so this will be the string. So we are getting this output. So how we are getting that? So you can see this is a string. So we it is written, you can see it will be 10 letter long subsequence. So we have to find all the unique possible subsequence which are repeating in this string of size 10. So this string is of any size, okay, we have to find. So when we start from this, you can see this C. So you can see this is 5 A's and 5 C, so it is 10 character long, okay. So should be 10 character long, it is a constraint. And you can say this A and this C, this is a till here, you can see, so it is also 10 character long. So you can see this is repeating. So what we have to output is output one of this. You can see these are repeating, so it is a unique combination. You can see we have to return this. And when you see here, now let me erase this. So for the second string substring, you can see this C 5 times and this A, and again this starting from here C and this A. So you can see it is also repeating. So it is unique actually. The previous one was A is starting from A, this is starting from C. So this is also repeating, or this occurs more than one time. So this is what our question requires. It has told that we will be given a string, this will be given, and what we have to do is we have to search for all the possible substrings which are coming or occurring more than one time. Not one time, it should be occurring more than one time, then we will output it in our this array. So what we have to do, we have to simply traverse this array, and let me show you what, there will be two solutions possible for this video. I'm like resisting this to this, keeping it to this only. So you can do it also using the rolling hash, but I will be explaining you using the hashing and the set. So what is actually hashing? If you would have used like Hashmap or a dictionary, you would be knowing, but if you don't know, I will explain you simply. So Hashmap is basically a key value pair. So it is a key value pair or data structure, you can say. So all the entries in the hash map or the dictionary will be consisting of key and value. So what will be our key in this example? So as you know, we have to find all the possible substrings. So our substrings, and we also need to check the their count. If it occurs one time, so we cannot output into our output because it is not repeating. We have to output all the repeating substrings. So that is why we will have to maintain a count also. So what we can do is, for the key part, we can simply use the string substring that we are getting as the key, and the value will be the count, that is it, the number of times it is occurring. So this is what our hash map will do. So what we'll do, we'll simply this traverse over this array or this string, you can see, and then we will find a key for every 10 you can see the base case. There is also one base case that you should check. If the size of the string that you are given is less than 10, then you will simply return 0, because the empty this string vector of string, because there won't be any possible substring because it is not of length 10 only. The total string is also not length 10, so it cannot give any output. So what we'll do, we'll simply traverse over this string that we are given, and we will, like, I will be over here, okay, I will be here, then we will extract a substring from this total string, from the starting from I till 10 letters or 10 characters. You can see it will be extracting the string from here. So this will be stored in our temp. Okay, we will store this into our temp, and then what we will do, we will add it to our hash map. If it is present in hash map, we can simply increment the value. If it has occurred already one time, so it has not occurred any of the time, so what we will do, we will simply this, you can see this string will be copied to the hash map. It will be the key of the hash map, and then its value will be number of time it has occurred. So it has occurred one time. Then when for now the next substring that we will extract will be from the next character. So we are traversing over this linearly, you can see, so we won't skip any this solution possible. So now it will extract from this a, starting from this a, and 10 letters still here. You can see this is not repeating, it will be again saved to the hash map. And similarly all the strings that are possible will be substrings that are possible will be saved into the hash map, starting from the I, okay, till I. So our, like, I will write here also, so we will simply use the substring function. Okay, so I'm just writing the substring, it is not the particular syntax of any language. So it will be from the s is given and I. So you can see we will write is like this s substring. Okay, wait a second. So it will be like starting from I till I plus 10. You can see I plus 10. So what we will do, we will simply extract all the possible substrings from a particular string, and we will add it to our hash map. And if it has occurred more than one time, then we will simply increment the count of that particular substring. So this is what in hash map we will do. And at last, when we will be having our hash map with all the possible substrings and all their counts, then we will traverse over the hash map and we will check for this particular value. You can see it has occurred again from this ACC, so its value will be 2 at the last. So similarly more values will be added, but I'm keeping this short. So you can see this will be returned, and when we will be having this, the hash map will be containing all the substrings. We will traverse over the hash map and we will check for the count. If the count is greater than 1, that means it is repeating, so we will add it to our vector or the result vector that we have to return. Add the key of the this pair. So we will add the key to our output. So this will be a simple hashing solution, and it will take the time complexity of O of n, because we are traversing over this string. And you should also keep into mind that when we traverse the I will start from 0, but it will run till only n minus, if this n is the size of the string, so it will run till n minus 9, because we have to stop before this character. If it is like 1 to 3 and this 3, so it will have to stop from here. After this it cannot make, if it I comes here, so it cannot make a substring of size 10, so we will have to stop it till here. So this will be our last element. So the time complexity will be n and space will be also n, because we are using the hash map. So let's see the code for this hash map, then I will explain you the similar code, similar solution that is using the set. So this code will be in C++. So let's show you. So you can see this is a simple code using the hash map. So what we have to do, we have to simply define the result vector that we have to return of type string. Then we will check for the base condition. If the string size is less than 10, then we will simply return the result. Result will be first of all empty. So we will simply return the empty list, because we don't have any substring. Then we will initialize the unordered map, and the key will be of type string. As I told you, this is our type string, and the value will be of int, because int is the count. The key will be the substring that we are having. And then what we will do, we will simply traverse over the whole string. You can see I will be 0, and it will be running till size of the string minus 9. Because at some point we have to stop it, because after that it won't be getting the substring of size 10. So that's why we will have to stop it. So that's why, so you can see here we can in C++ we can simply do map. This is m is our map. You can see we have initialized the map and the s dot substring. So this I've written like this. This is not the particular syntax as I told you. So you can see it will be s dot substring in this and you can see passing the I and 10. So that means I will be like, if I is 0, for example this I is 0, then 10 means we will pass 10, so it should be of size 10. That means I plus 10, it will be this I plus 10. So I plus 10 will be here. So it will extract this substring from this particular string, and it will store into the map as the key and increment it. If it has not occurred, so it will be set to 1. If it has occurred, so the value will be incremented simply to 2, 3, and similarly till how much time it occurs. Then what we have to do, after we have like got the hash map, we will simply traverse over the hash map. So you can see this is the syntax for traversing it, and then we will check if the value I dot second will be the second in the pair. Second is this value. So if the value is greater than 1, that means it is repeating, it is greater than 1. So we will add it to our result. Emplace back. Emplace back is actually faster than the pushback, so I'm using this emplace back. And we have to add the key. Do keep this in mind. I dot first will be the key. So how to assess this pair? You can see I dot first will be the key and I dot second will be the value. So we have to simply return the result. Then let's submit the solution, and then I will explain you simple hash map set solution. So you can see it got submitted. Now let's see the set solution. So in set, actually it is simple. We have to simply traverse the string like that only, and when we are getting the we will actually, when we are getting our substring, we will simply add it to our set. So set is actually a pair of, you can see it is similar to list, but it cannot have any duplicate values. It will only have the unique values. If you see set is having one value, okay, if we try to add one again, so it will be not taking the input one and added it to the set, because it has only the unique values, if you know that. So it will like 1 2 3, only the unique values will be entered and entered. So when we are traversing the string, like here also we traverse the string, like it's the same formula, same thing will be used as short substring I and I plus this 10. We will, if when we get a string, so for example s is our substring that we are getting, then we will add it to our set and we will check if s is already in set. Then what we have to do is we have to simply, we will make the set of the result also. For the result that we have to return, we will make a set for that also. We will add it to the result set, you can see. So this is our set, for example. Then when we traverse the string, okay, we will add it to add it here. This a or this size of 10 is added here, and this is the result set. You can see this is the result set, okay, and this is the scene set. You can see scene, because if we have seen it, so we will add not add it into this. So we will check. So a it will be added here. So it has not been seen, so it will simply add it. When we again come to this, so you can see a, it will be also added, it will be also added. When the I will be coming here, so it will be extracting this substring, so it will be adding, it will be checking if this value is in this scene set. So yes, it is in scene set, so that means it has occurred more than once, that is why it is coming again. So we will simply add it to the result set that we are having. So why we are using the result set here? Because it will be adding the more than, if we use a list, it will be adding the duplicate values also here. If a c occurs again, so it will add it 2 times. So that is why we are using the set for output also, and for the scenes also we are using the set. So it will be also having the time complexity of n only. So for hashing, the time complexity can vary from n to log n, so that will be you should keep in mind. So for set time complexity will be n, and the space will be also n. So let's see. So it will be actually faster than I have written this code in Python for those who don't know C++. So let's see. So you can see in Python we have to simply this is our input that we give string. Then what I have done is we can simply initialize the scene set and the result set. So scene set, we will also check for the base condition. If the length of the string is less than 10, we will simply return the empty set that we are having. So then we will check for this traverse over this string. You can see 0 to length s or minus 9. Then this is how we extract a substring in the Python. You can see I and I plus 10. Then if we will check if the stamp is already in scene, so if it is added, the string is already added in this scene, that means it has repeated again. So that's why we'll add it to the result array. You can see a result set in this case. So you can see result dot add temp. This is the syntax for the set. You have to use add. Okay, then if it has not been seen, so we'll simply add it to keep adding it to the this scene set. Because if you add the multiple same values, you can see if we are adding same string again, so it will be not taking that again. So set will be having only the unique values, it will don't do anything. So that's why we can add that like that. So let's see, submit the solution. So I hope this video helps you. If you are not you have any doubts, so you can do ask in the comment section below. You can see this solution using the set in Python ran faster than the solution in C++ using the hash. So this is not usually the case. So you can see this is like rare, really rare, you can see. So I hope you like this video, and guys, do like this video and subscribe this channel and share this video for more such like probably programming solutions. Thank you for watching, guys.